Okay, I come back with 8.2 row operation and Gaussian elimination. So let's talk about row echelon form. We use row operations corresponding to equation operation to obtain a new matrix that is row equivalent and simpler form. So this is a general form for row echelon form. So you can see that all the diagonal of the matrix here has to be number one, right? And above of it could be any number, right? Could be anything. But below it has to be equal zero. Below of the diagonal, it has to be equal zero. So that is called row echelon form. Okay, so what is? Let's talk about guideline for the row echelon form. First, in any non-zero row, okay, let's say in any non-zero row, the first non-zero number is a number one. So let's come back with the matrix. So if there's a row that have no zero non-zero, then the first non-zero number is a number one. So that should be the first row in here, right? You see the first row in here, A and B's, because A and B they are non-zero number, right? So the first number has to be number one, and it's called leading number one. Okay, so this guy is leading one. Okay, and then any all zero rows are placed at the bottom on the matrix. So so you can see like any all zero rows are placed at the bottom on the matrix. So the bottom of the matrix, if we have like a all zero, it has to be at the bottom. But in this case, we don't have that. Okay. Number three, any leading one is below and to the right of the previous leading one. Okay. So if I come to the next leading one, I have to go to the right. Go to the right of the previous leading one. Okay. If this one is below the first leading one, then I have to go to one right to that. Okay. Okay. Now let's move to number four. Any column containing a leading one has zero in all other position in the column. So so let's move to, like, let's say any column contain a leading one. So say this, let's say this, the first column here containing leading one, right? Then it has zero in all other position in the column. So it's 0, 0. Okay. So that is it. Oh wait, this actually a wrong one, because if the second column here I also have number one, but A is not is not a zero. So this one should be a wrong statement. Should be a wrong probability. Okay. Sorry, people. You should not have this in the notes. I don't know why we have it. So please cause it's not. It should not be there. Okay. Let me take a screenshot of this to tell to the my department. Okay. So let's move down. Okay, so this is the row operations. We have the first column is talking about the symbols. The second one is row operation. It's similar with the section 7.4 for the equation, right? E sub 1 is 2, something like that. It's same thing. So in here, instead of E is using R. R is stand by row. So it's like RI interchange with RJ over here, and KRI, K multiplied with RI gonna be the new RI. Okay. And then RJs plus K multiplied with R sub I will be the new RJ. Okay. So we is add a product of a row multiplied by a constant to another row. Okay. So let's see what's going on down here. Okay. We want to do Gaussian eliminations. So the Gaussian elimination method refers to strategies used to obtain the row echelon form for a matrix. The goal is to write a matrix A with a number 1 as the entry down the main diagonal. So you want to have 1 in the main diagonal and have R0 below that. Okay. And that's called Gaussian elimination. Okay. So all right. So here is the way we want to express by math notation. So you see the matrix the matrix A was with all the non-zero number, and after using Gaussian elimination, now it changed to be a row echelon form, right? With diagonal is 1 and all zero number below. So that's what we want. And let's see. Let's do an example one. Okay. So firstly, it's a use Gaussian elimination to solve the given 2x2 system of the equation. Firstly, I would like to change this to be augmented equation. So I have 2, 3, 6, and then 1 minus 1, and then 1/2. Okay. So far, so good. And you know that's the first one is say row 1, and the second one is say row 2. So what I want is I want to make the diagonal here have to be equal to 1 first. So say step 1. Okay. Make the first how can I say, make the element of the column 1, row 1 and column 1 be equal to 1. Okay. So what is A11 here? A11 is the element that stay in the first row and first column, right? See that? So how can I make it? I need to, you can interchange, row 1 and row 2 to make A11 become 1. Okay, so I'm gonna interchange row 1 interchange with row 2. So now I have new one is 1, -1, 1/2, and then 2, 3, 6, right? So here's new one. So after having the first column have, the first row have leading 1, okay? Now I'm gonna make, let me use, I'm gonna make the element below become 0. So step 2, make make all element below A11 equals 0. Make all elements below A1 to be 0. Okay, to be 0. Okay. So what does that mean? I want to make this number 2 become 0. How can I do that? I want to change row 2, right? So now I want to have row 2 changing by adding with a k multiplied by row 1. What is k in here? Okay, what is k in here? And that will make new row 2, right? What is k in here? Okay, so let's use the coefficient for row 2 now. It's row 2 plus with k, I don't know k yet, and multiply with 1 from row 1, right? And then equal to 0 because I want to make it equal to 0. So then now what is the k going to be? You will have k equal to -2 both inside. So what is the -2? So you're going to have k equal to 2. So this actually like a draft for me, right? So I actually now gonna have k equal to 2. So I will just put -2 here, multiply with I1. Okay. So let me clean this up so we have space. Okay. So the step actually did you should actually do it like a draft paper. Okay. So this is the real step, the real one that you need to do to make the first elements of the second row become 0. Now what I'm gonna have is okay, the row 1 will stay the same, right? -1 and then 1/2. But now row 2 will be okay. So I have I'm gonna put the I'm gonna have no, I'm gonna have the graph here, right? So the first element here should be equal 0 easily because you know we did by graph before, right? The second one will be so you have 3 times with 3 plus with -2, 3 plus with -2 multiplied with -1, right? So multiply with negative 1. So what is that going to be? 3 plus with 2 is 5. So I'm going to put 5 here. Okay. Similarly, for this number, it's going to be 6, right? You plus with negative 2 multiplied by 1/2. Okay, multiplied by 1/2. So this will be 6 minus 1, which is equal to 5. So put 5 here. Okay. So now we are having number 5. The second rows now having number 5, but haven't have the leading one yet, right? So we need to make number 5 here. Let me change the color. Number 5 here to be number 1. Okay, so say step 3. Make make the make below leading one. Okay. So how can I do that? I'm gonna have row 2 changing by multiply with 1/5. That will make a new row 2. So I will have 1 minus 1, 1/2, and 0. 5 multiplied by 1/5 going to be 1. 5 multiplied by 1/5 going to be 1. And then now you are having Gaussian. You are having actually you are having the row echelon form here. Okay. What we want, what we're gonna do if we have Gauss elimination to solve? Let's move back a little bit. Okay. So okay, they didn't mention after this what we do, but I'm gonna say. So after this, you're just gonna use back substitute. I mean, you're gonna change it back to the system equation system. Okay, so it's going to be x minus y equal to 1/2, and then this will be 0x, right? 0x plus y equal to 1, right? So now you can easily know that use step 4 back substitutes, right? You will use y equal to 1 and substitute back to the first equation. You have x minus 1 equal to 1/2, then x equal to negative 3 positive 3/2, because plus 1 both sides you have actually 3/2. So that should be the answer. Okay, so the solution should be you can write as x equal to 3/2 and y equal to 1, or you can write as order pair is 3/2, 1. So Let me circle this as the answer. All right. So that is done for this column. Then move down. So similarly, we're gonna do example 2 here. Firstly, I would like to make it become the 2 by 2 augmented matrix. So 2, 1, 1, 4, 2, 6, and then dash in the middle. Okay. So so I want to have 1 for the A11 here, right? A11, right? I want to make step 1. Make A11 the first term, the first elements in the first column and first row when we go to be leading 1. Okay. So how can I do that? You're gonna make row 1 multiplied by 1/2, right? So then you can make the number 2 here become 1. So that's gonna be new row 1. So now let's have new matrix 1, 1/2, 1/2, right? 1/2 times 1 is 1/2. 1/2 times 1 is 1/2. Okay. So now, so we have the second row when they're not chained at all, 4, 2, 6. Okay. So remember that what I just did for this step is I just multiply 1/2 with the first row over here, or this one, right? Okay. Now, step 2. Make the element below A11 in the same column become 0. Okay. So what does that mean? I want to make number 4 here become 0. Actually, sorry, number 4 here, because we have new matrix already. So how can I do that? I want to have row 2 changing by adding k multiplied with row 1, and that will make a new row 2. Okay, so let's figure out what is k here. You should understand that, like let's work sidewalk here, right? You have like the first elements of row 2 is 4, right? Plus k times the first element of row 1 is 1, equal to, I want to make it equal to 0, so k should be equal to -4. Okay, so easily you just gonna change this k become 4, -4. Oh, not nice. -4. Okay. Ooh. Okay, now it's better. Okay, so now let's make the matrix. So row 1 will not change, right? So just keep row 1, 1 half, 1 half. Second one now have the first one should change to become 0 because 4 4 times plus negative 4 times 1 equals 0, right? So the second one gonna be okay. The second one is 2 plus with negative 4, right? Time this one, right? 1 half. Okay. Then now it's gonna be 2 plus with negative 2. It's going to be also equal 0. 0 here. Okay. And the last term, I have 6 plus negative 4, right? Negative 4 time with 1 half. 1 half over here. Okay, not on this 1 half. Okay. 1 half. Now it's going to be 3. Oh, sorry, 4. Because 6 minus 2 is 4. So I have 4 here. Okay. So now we have new equation and new system, new matrix, and I'm gonna change it to be the system of equation. So it's look like 1x plus 1 half y equal to 1 half. Second one gonna be 0x plus 0y equal to 4. But please take a look at the second equation on the second row here, right? You see it actually means 0 equal to 4. Can you make it true? It's always false, right? It's always false statement, right? So I'm gonna say no solution right away. If you see something like the bottom of the two left-hand side term with all 0, but the right-hand side term will be a non-zero number, there needs to be no solution. Okay. So let's move there. So this is another example, and they want us to solve system of linear equation using matrix. Okay. So let's move and make it to become matrix. So 1 minus 1 went 1 and 8. Okay. So 2, 3, negative 1, negative 2. 3, negative 2, negative 9, and 9. Okay, separate it. Now, I will make it quick. Okay. So I'm gonna right away use step 1 by, because the first step I actually have this one is leading 1 already. So I'm gonna skip that step. Now I just wanna make this the one below 1. Say step 1. Make all elements below A11 in the same column. To be 0, right? So what does that mean? I want row 2 changing by adding with what to make what multiply with one. You can see that you should multiply it by -1 and -2 to make it become new 2, right? Okay, so also you want to change the R3, right? If you want to change something, you put it first. So put R3. You're gonna add with something multiply with R1 to make it become 0 for the first term. So you know that was 3 here, and so then you should multiply by -3 for the first one, right? -3 for the first R1. Okay. So now you're gonna have R3 new. Okay, let's see how can we make it. Okay, so watch out for this one. So I have R2. Let's have first one is not changing at all. So 1 minus 1, 1, and then 8. Okay. Now let's do the second one. So let's have flag over here. So I'm pretty sure the first term should be equal to 0, right? Now move to the second term here. Let's use other color. Okay, so second term here. I have 3, which is R2, right? I'm plus with -2, right? -2. Multiply with R1, which is here. -1. Okay. So what do you have? 3 plus 2, 5. Easily. Put 5. Now what about the last term? -R1 and -1. Not the last one, but just like the third one. -1 for the R2. I plus with -2 and multiply with, right? Multiply with this one, which is number 1 from R1, right? So I have -1 minus 2 will be -3 easily. Okay. So now I have, what else? I have next one, -2. I plus with -2, and then I multiply with 8. Multiply with 8, right? What do I have now? -2 minus 16, -18. Okay, so put, oh, I forgot to put -3 here, and -18. Okay. So we're done with row 2. Now we move to the row 3, right? So I need more space. Okay, now how about row 3? Row 3 start with 0 because 3 here should be 0 after you adding -3 times 1 here, right? Easily. What about the next term? Using -2 here, put -2. I add with -3 here. multiplied by R1. Where's your R1? This one still, -1. What is that equal to? -2 plus 3 gonna be 1. Put 1 here. Okay. Now, next term, -9. So -9. Plus with -3. -3 was here, right? Then multiply with row 1 again. This one again, which is number 1. So what is that going to be? -9 minus 3 will be -12. And the last one, put -12 here. The last one, 3 was number 9. Let's put 9. I plus with -3 multiplied by with 8. Okay, what do I have now? 9 minus 24. 9 minus 24, we're going to be 15. So put 15. -15. I mean, almost mistake. Okay. So everything look good now. Let's check one more time to make sure. So okay, so look, everything look good. So what's the next? I need to make, let me use the other color, maybe green one. Okay, I need to make this, oh, wait. I need to make this one to become number 1 because the leading one for the next row. Okay, so step 2, make leading one for second row, right? So how can I do that? Row 2 multiplied by 1/5. That's gonna make its 5 become 1. So then I have 1 minus 1, 1, 8. First row should not change. Second row will be 0, 1. Okay, what about this guy? -3. You know what? I have another idea. Why don't we just switch row 2 and row 3? That's gonna be easier. And it could make our matrix better. You can use the way before, but that could make some fraction and maybe you're not happy with that. So I'm gonna just interchange row 2 and row 3. So what do I have now? I will have 1, -1, 1, 8. So 0, 1, -12, -15, right? You see that I just interchange the first, no, sorry, the second row and the third row, right? So now the third one should be 0, 5, -3, -18. Okay, so look good. Let me go down a little bit. Hope we have enough space. Let me see down here. Still, oh, they don't have enough space for us, I think. Okay, let's see if I can handle it. So step 3. Step 3, what you need to do is you want to make this 5 become 0, right? So make all element below A22. A22 is element in the second row, second column, which is this one, A22. Okay, so A22 in the same column to be 0. So now what do I have? I will use 3. I will change at 3, right? So I will add with something with K multiply with R2. At this step, you don't want to touch R1 at all because R1 is done. Okay, you're gonna just use you're just gonna change R3 by adding with non-zero number multiplied by R2. Okay, so what is that gonna be? So you should understand that F3 was 5 here, and if you want to make it become 0, you need to subtract by 5. So that means you need to multiply it by -5 for the number 1 here, right? So that means what? That means K should be equal to -5. And now you're going to have new 3. So how does that look like? So I have 1, -1, 1, 8, 0, 1, -12, -15, and then, okay. Now for the last term, 0, 0, okay. What is about this one? Okay, you need to have work aside work. So I have -3, right? Was from here. You multiply, no, sorry, you adding with -5, multiply with row 2. So row 2 is here. So multiply with -12. And what is that going to be? Okay, let me use my calculator. So I have 3 negative plus with -5 times with -12. So now I have 57. Okay, so I put 57 down here. 57. Oh, that one makes it too big. Okay, and so, and then the last term was -18 here. I plus with -5 multiply with row 2. So then -15. And what do I have now? Use the calculator. 18 negative plus with 5 times 15. You still have 57 or so. Wow. Amazing. Did I make any mistake? Let me check one more time. 5, 12, okay. 15, 5, 15. Okay. So look, everything look good. So the last step, maybe you can just let me see. You can make this one become 1, right? So you can write as step 4, make leading one for the third row. So by using R3 multiplied by 1/57, then you will have this become the new one as 1 minus 1 1 8 0 1 negative 12 negative 15 0 0 1 and 1, right? Because both of these divide by 57. So please continue to solve it by back substitution. By the cell, you can handle that. Uh, you may firstly have to convert it to the maybe you should say, I should say, like, convert it to the system equation. System equation, and then back substitute. Okay, so after that you will easily solve it. Okay, let me know if you don't get it. You can go to my Zoom Live to talk with me. Okay, now we move down to the next page. So big cell. Okay, let me see. Okay, a sorority held a bake sale to raise money and sold brownies and chocolate chip cookies. They priced the brownies at $2 and the chocolate chip cookies at $1. They raised $250 and sold 175 items. How many brownies and how many cookies were sold? So usually in the problem like this, I will take a look at the last sentence and say what the question about. It's talking about like how many brownies and how many cookies were sold. So I will say, oh, okay, that X is number of brownies. Okay, and then Y is number. Okay, so using table with say brownies, cookies. And so let's say number is here. Let's say price is here. So the number of brownies is X. Number of cookie is Y. And the price of brownies will be $2 for each. So we have how can I how about I'm gonna say instead of price I'm gonna say raised. So $2 for each. That means 2 times X going to be the amount of money that you raise from brownies, and then for the cookie going to be $1 for each. So 1 times 1 is 1. So 1 to make it clear. Okay, so then I have another column, say total. So total number of items in here are going to be X plus 1 equal to 175. given here, right? Items. And raised for the amount of money is going to be 2x plus 1y equal to 50 is given. Okay, so that is the reason why we have the equation that the system equation that x plus y equal to 175, and second one is 2x plus y equal to 250. So in here we actually can convert it to be augmented matrix as 175 2 1 250. Okay, so then you can right away say step one, because we have the first column, we have leading one already, so just gonna move to the step that you're making all element below A11 in the same column become 0, right? So what does that mean? I want to make this number 2 equal 0. So how can I do that? Row 2 is changing by adding a k multiplied with row 1. What is that? Okay. Should it be -2? Right? It is. And that will be the new row 2. So I have new system as 175. Okay. Yes, I will. Okay, so the number 2 add with -2 times row 1 is 1 is 0. Right? So 0. Number 1 plus with -2 multiplied by 1 here equal to 1 minus 2 equal to -1. -1 here. Okay, so now come to the 250. The last one, 250. Plus with the -2 multiplied by 175. Now what is that going to be? Use a calculator. So actually going to be 250 minus 2 times 175. 9100. So let's make sure I have negative 100. Negative 100. Negative 100 here. Okay. So let me make so the next step is I want to make this guy become 1, right? So step 2, go down a little bit. Step 2, making leading 1 for second row. How can I do that? So I'm gonna just multiply it by -1 for the second row as we make the new row 2. So you have 1, 1, 175, and then 0, -1, and then -1. Oh, sorry. Multiply with -1 already, so I put 1 and 1 in this. So that's going to be row echelon form. So that you can change it to be system of equation now, which is x plus y equals to 175. And the second one will be y equals to 100. Okay. Now back step 2, step 3. Back step 2. We have y equals to 100. We have x plus 100 equals to 175. That will give you x equal to 75. So the solution will be x equal to 75, y equal to 100, or in the other form is 75, comma 100. So let's label it as I want to see that. Okay. Okay. So we have just finished section 8.2, and I will see you later in section 8.3.